Alright everyone, let's actually put our law of sines to use. And remember the law of sines, sine of alpha over A equals the sine of beta over B equals the sine of gamma over C. And this is our triangle, how we typically draw it. Now of course it can be rearranged any way we want. We can put these angles any way we want, but side B will always be opposite of beta. Side alpha, A would always be opposite of alpha, and so on. Okay? So keep that in mind. Alright, so first case we're going to look at. This is going to be the angle side angle case. The angle side angle case. So here's our triangle. Here's our triangle. And this is 45.1 degrees. This angle here is 75.8. 75.8. This is gamma, B, alpha, and 10.2 will be this side. So notice, you got two angles and an included side is how we say that. Okay, two angles and included side. So step one, whenever you're given two angles, we're going to solve for this whole triangle. So your goal for every one of these problems is to find alpha, beta, gamma, A, B, and C. Now you were given alpha and you were given beta. So alpha 45.1, beta 75.8. And you were given side C, which was 10.2. Now, whenever you're given two angles, okay, it's very easy to solve for the third angle. How do we do that? We'll subtract them from 180. So subtract the sum of these two angles from 180, and you should get 59.1. So that is our gamma. Now it's noticeable that all these are acute angles. Look at the triangle. You should be able to generally tell. Now I don't recommend going by pictures. That's why I recommend solving it out. Pictures can be misleading from time to time. But in general, looking at that, you would be able to say, yes, all of those should be acute angles. And a little math joke, okay, for those of you that are bored to death. I didn't say acute angle. That angle is not cute like a baby. Acute, okay? So that's just a little math joke. You have to break up the monotony sometimes. Okay, so letter A. We want to solve for letter A first. Well, this is where we can use our law of sines. So how do I want to do that? So I know I want to solve for letter A, so I'm going to have this ratio. But which ratio do I want to set it equal to? I've got two choices. I can either set it equal to sine beta over B or sine gamma over C. Well, we're going to set it equal to sine of gamma over C. Now, why is that? Because we know both the angle and the side for gamma. The angle and the side. So this is the sine of 45.1 degrees over A equals the sine of 59.1 degrees all over 10.2. Alright, so word of advice. When you get ready to cross multiply and divide to solve for A, do not round until the end. Okay? Do not round until the end. So when you type this in the calculator, watch how you need to type this in the calculator, kind of like I'm writing it here. The sine of 45.1, 10.2 times the sine of 45.1, all over the sine of 59.1. Okay, so that keeps you from having to round if you do that, okay? And then now at the end we can round. Now notice in the beginning all of our values here have 3 significant digits. So we want 3 significant digits in our answer. So 8.42 is what you need to round to when you get this answer for A. 8.42. Okay, so that's letter A. All right. Now here's the problem that students have. At this point, they see A, B, and C there, and they see that they have A and C, and students want to use the Pythagorean theorem. Why can we not use the Pythagorean theorem? Well, hopefully you're banging your head against the screen because you're saying it's not a right triangle. Remember, the Pythagorean theorem can only be used with a right triangle. So what we need to do here, we need to use our law of sines again. So I'm going to try to solve for the sine of beta over B equals, and I'm going to do our sine of gamma over C again. Simply because C was given to me and gamma was easily found without having to do any rounding. So it's going to make your answer more accurate, okay? So we're actually trying to find B here. So plug in your info. Sine of beta, so that's 75.8 all over B equals the sine of 59.1 all over 10.2. So same thing again, same process again to get letter B. Cross multiply and divide, and you should get to 3 significant digits, 11.5. So once you have solved for all of these, so once you've solved for all of them, you are good to go. You have now solved this problem. Okay? So that is an angle side angle problem. They are typically the easiest ones in my opinion. They're the ones I like. I personally like those because they're straightforward. But let's look at another one. Let's look at another case. And for this case, let's look at this case is going to be angle, angle, side. Angle, angle, side. So here's our triangle. And now you could have, we probably won't do any on this video, but you'll probably see on homework some application style word problems with this where you have to read it. Now, the best way to do these is to draw the triangle when you have an application problem. If you can draw it, you'll be able to see it, okay? So, recommendation there. Alright, so let's say alpha is going to be 63 degrees. Beta is going to be 38 degrees. Gamma is not found. And letter A is going to be 12. So we want to find gamma, we want to find B, and we want to find C. Okay, so again, gamma is going to be the easiest to solve for. What do? We subtract from 180. So it is by far the easiest to solve for. Alright, so we have alpha, beta, gamma. Alright, so we know alpha 63, we know beta's 38, now we know gamma 79. All of these are acute, and we know letter A is 12. So now what are we going to do here? Hopefully you learned from the last problem. We're going to take our law of sine, and now we're going to, I would solve for B first, then do the law of sines again to solve for C. So the sine of alpha over A equals, sine of alpha over A equals the sine of beta all over B. So go ahead, plug in the sine of 63 over 12 equals the sine of 38 all over B. So get your calculators out because I forgot to do this one ahead of time. So let's punch this in our calculator together. So I'm going to do the sine of 38 times 12 divided by the sine of 63. Alright, go back and I didn't do it right because I typed it in the calculator right, but my answer didn't come out right. Why do you think that is? Make sure all these angles are in degrees. Make sure your calculator is in degree mode. And if you do, because we have two significant digits on these, I'm going to round this to 8.3 for B. 8.3 for B. Alright, so we found B. Now go in here, and we're going to do this again. But this time, we're going to solve for C. So this is still sine of 63 all over 12. The only difference here, this is going to be the sine of 79 over C. So do your cross multiplying and dividing, and you should get 13 for this one when you round to two significant digits. So C is 13. Alright, so now these are the two cases. These are the two easy cases, ASA and AAS. These are the ones that you should get right. This is just applying the law of sine. Okay. On the next video, we're going to do this. Next video will just be on the ambiguous case, so that should tell you something about it, since one video is on just the ambiguous case. So keep that in mind as we get ready to start that. So I'll see you on the next video.